Now we're moving on to obtaining information from or about the graph of a function. So there's one really critical thing that we need to start out looking at here, and this is a pretty simple statement, but you don't want to miss this, because this is this thought and this definition is going to be used in a lot of problems, a lot of homework questions, and this is really a fundamental idea that you need to be aware of. Since if xy is a point on the graph of a function, then y is a value of f at x, or that is y equals f of x. So what does that mean? Okay, if we have some point, call it 2, 6 on the graph of our function, it's an x and a y value, that means that, okay, y equals f of x. In other words, 6 equals f of 2. Okay, that means we plugged an x value of 2 into that function, did some math, and got a result of 6, a y value of 6. And so 2, 6 being a point on that graph means that 6 is the same as f of 2. All right, and we'll see why that's a useful thought and kind of what that means here in just a little bit for some of these questions. But again, that's a fundamental thing that you need to be aware of and understand. All right, so it says let f be a function whose graph is given below. So is this a function? Think about that vertical line test. Okay, it does pass the vertical line test, and notice we've got a bunch of points on this graph here they've given us. Now, a lot of these points have pi in them. You can see the pi showing up here. Don't let that throw you off. Okay, don't freak out or anything because of the pi. I think you'll see here in a minute that really doesn't complicate things too much for the questions we're going to be looking at. But let's go ahead and look at the first question. What are f of 0, f of 3 pi halves, and f of 3 pi? Okay, so again, what is f of 0? How are we going to figure that out from this graph here? Well, it goes back to this statement that we said earlier. Okay, this thing we were talking about. F of 0, okay, that 0, that's an x value. Okay, f of 0, that's f of x, so that's an x value. So we need to know what ordered pair on this graph has an x value 0. Okay, if we look, what about this point right here? That's got an x value 0, right? So if the x value is 0, y value is 4, well, that must mean that f of 0 is 4. Okay, for f of 3 pi halves and f of 3 pi, again, these are x values. So if I go back, 3 pi halves, let me find the point with the x value 3 pi halves. It's this guy right here. There's my x value 3 pi halves. What's the y value? 0. So f of 3 pi halves is 0. That's that point. 3 pi halves 0. And then f of 3 pi, again, just finding where's 3 pi. It's right there. The y value that goes with that, -4. Again, that's the point, 3 pi, -4. And so f of 0 is 4, f of 3 pi halves is 0, f of 3 pi is -4. Without doing any kind of math, we're just pulling those coordinates off of the points. Part B, what's the domain of f? Okay, if we go back, the domain, again, if we're looking at a graph, we want to think left boundaries and right boundaries. Is there a left boundary on this graph? Well, if you'll notice, this graph dead ends right there. It doesn't have an arrow saying that it continues, right? It just stops. So that means we do have a left boundary at, what's that x value? That's an x value of 0. Do we have a right boundary? Yeah. It's the right boundary there. Graph just dead ends. It stops at 4 pi. So our domain goes from 0 to 4 pi, and notice I'm putting square brackets. That's showing that those endpoints are included in that domain. We do have points with x value 0 and x value 4 pi. Okay, next question, what's the range of f? Okay, the range of f, now I'm thinking upper and lower boundaries. So, okay, for the range, what's my lower boundary on this graph? Well, the lowest this graph goes, both of these points have y values of -4. So that's the lower boundary. The upper boundary, well, we got 3 points, all with y values of 4. So the lowest point on this graph has y value -4. The highest point on this graph has y value +4. So the range goes from -4 to +4. List the intercepts. Okay, so do we have any intercepts on the graph? Any points where it crosses the x or y axis? And we can actually say crosses or touches. If it touches the x or y axis, that's also considered an intercept. And so we do have a point where it crosses the y axis there. And then there's 3 points. I'm sorry, there's 4 points where it crosses the x-axis. So the first intercept is 0, 4. Copy these here. And then pi halves 0. 3 pi halves, 0, 5 pi halves, and then 7 pi halves. Those are all the intercepts for this graph. Okay, you thought we were done, didn't you? We got several more questions here. How often does a line y = 2 intersect the graph? Okay, how often does it intersect the graph? Okay, where is that line y = 2? Okay, if we draw a line with all y values of 2, what would that look like? Wouldn't that be something like that? There's the horizontal line where all the y values are 2. And now how often does that intersect our graph? Okay, looks like we've got an intersection. Whoops. Okay, we've got an intersection here, 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 and here. So it looks like that thing intersects our graph 4 times. Okay, for what values of x does f of x equal 4? Now again, if we say f of x equals 4, remember a minute ago we said that f of x equals y. And so that's the same as asking for what values x do we have a y value. Here f of x is -4, so y equals -4. What points have a y value of -4? Okay, so what points have y values of -4? Looks like maybe this point and this point. And so if f of x is -4, remember that's that y value, x could be pi or it could be 3 pi. Both of those are possible answers. So x equals pi or 3 pi are both answers for that. And I believe this is our last question. For what values of x is f of x larger than 0? Now again, that's the same as saying is, because again, f of x equals y, right? And so that's the same as saying, for what values of x is y larger than 0? So where on our graph do we have y values larger than 0? This graph's getting a little busy. I'm going to erase some because we just got a lot going on here. Now, that boundary where y is larger than 0 sits right there on that x-axis, right? So where's our graph? Where on our graph do we have y values larger than 0? Okay, that's going to be from this point here, 0, 4, all the way down to where it touches the x-axis, where that y value is 0. But we don't actually include that point there, right? Because at that point, the y value is 0. F of x is 0. F of x is not larger than 0. We can pick it back up right here for this piece. It's where that's y value is larger than 0. And then again, there's a third piece here, including that endpoint. So if we wanted to describe this set of points where f of x is larger than 0, couldn't we use intervals? For what values of x is f of x greater than 0 from the x value 0 to the x value pi halves would be the first piece, from 0 to pi halves. And notice I'm including that endpoint at 0 with the square bracket, open endpoint at pi halves, not including that. Again, if we look here, we had an open endpoint there. Okay, our next piece starts at 3 pi halves and goes to 5 pi halves. Again, just looking at the x values. So let's do a union and go from 3 pi halves to 5 pi halves. Again, not including those endpoints there. And then the last piece goes from 7 pi halves to 4 pi. So those are the x values there. So again, union 7 pi halves to 4 pi. And we're going to put a square bracket on that last endpoint because we are including that point. We do have a point there that's included where f of x is greater than 0. Okay. Example 6, it says, consider the function f of x equals x plus 1 over x plus 2. Now we don't have a graph for this function, kind of doing this a little bit differently. Here in this last set of examples we just finished, we were given the graph of a function, and from that graph we got all this information. So we were basically using the graph to figure all that stuff out. For this question, we're just going to use this equation, this function, to figure out information about the graph without actually seeing the graph. So we're going to answer all these questions about the graph without actually looking at the graph. So the first question is the point 1, 1/2 on the graph of f? Now remember what we said earlier. If we have a point xy, that means that f of x equals y. Okay? So if we want to know if the point 1, 1/2 is on the graph of f, that means that f of 1 should equal 1/2. So is that true? Does f of 1 equal 1/2? Well, we could test that out real quick. Figure out what's f of 1. So that's 1 plus 1 over 1 plus 2. And we get 2 over 3. Now is 2 over 3 1/2? Of course not, okay? So since f of 1 is 2/3, then no, this point is not on the graph of f. So we say no. What point actually is? Well, if the x value is 1, then that y value must be 2/3 for it to be a point on that graph. So part B, if x is 2, what's f of x? And what point is on the graph of f? So this is pretty straightforward. If x is 2, what's f of x? So f of 2 is what we're looking for. That's 2 plus 1 over 2 plus 2, which is 3/4. So if x is 2, f of x is 3/4. And what point does that correspond to on the graph? Well, remember, this is our x value. So the x value is 2. When you plug that x value in and work it through your function, this right here is your y value. So 2 3/4 is the point that's on the graph of f. Part C, if f of x is 2, what is x? Now that's almost the same question we asked on part B, but I want you to notice that there's a little switcheroo that happens. Here we're saying x is 2. We know the x value, asking what is f of x. Down here we know what f of x is. We know that f of x is 2. We don't know what the x value is. So that's saying, okay, f of x equals 2. We plug some x value into the function, don't know what it was, did the math and got a result of 2. So if f of x is 2, that means that, okay, remember f of x is x plus 1 over x plus 2. So that means that x plus 1 over x plus 2 equals 2. Plugged in some x value there and got a 2. So to solve this equation here, first we're going to multiply both sides by x plus 2, which is going to clear out that denominator. So the left side there, we've got an x plus 1. And then we can distribute that 2 and get 2x plus 4. Subtract an x from both sides. And then subtract a 4 also. And we get 1 minus 4 is negative 3. 2x minus x is x. And there's our x value there. If f of x is 2, that means we plugged in an x value of 3. What point does that correspond to? Okay, here's our x value, negative 3. The y value, f of x is 2, so the y value is 2. There's our point. Then part D, what are the x-intercepts of the graph of f, if there are any, and what points do those correspond to? Now, we got to think about x-intercepts real quick and kind of make sure we understand what that question's asking. If we think about an x-intercept, I'm going to go back to this picture here just for the sake of talking about x-intercepts. The x-intercepts are these points right here where the graph crosses the x-axis. And what I want you to notice is all of these points have something in common. What do all these points have in common? They all have y values of 0, right? And that's true. Anytime you've got an x-intercept, the y value is going to be a 0. So going back to this question, what are the x-intercepts of the graph of f? Well, that's just asking, okay, when is the y value equal to 0? Or in other words, we could ask, when is f of x equal to 0? Isn't that the same question? Y and f of x are interchangeable. So when is y 0? When is f of x equal to 0? Now notice that sets up basically the same question as part C. If f of x is 2, what is x? Here we're asking, well, if f of x is 0, what is x? Okay, so we can set this up and say, all right, f of x is x plus 1 over x plus 2, and that equals 0. And so to figure this out, first again multiply by x plus 2 on both sides. To clear the fraction out, this one's a little bit easier. Bring down the x plus 1. 0 times x plus 2 is 0. And then if we subtract 1 from both sides, we get an x value of negative 1. And so we should have an x-intercept on this graph at negative 1. And then what point does that correspond to? Our x value is negative 1. What was our y value? Remember we said if it's an x-intercept, the y value is 0. So that's the point that corresponds with the graph of f.